I'm here to talk about wildfire, wildland fire, forest fires, and climate change. Fire is coming our way. So there's a picture of Ashcroft Reserve Fire at the time. It later became known as Elephant Hill Fire. And it's Friday, July 14th, so it's the week after the big rash of fires. And it's about 4:40 in the afternoon. Temperature is about 36, 37. That's Ashcroft in the bottom of the picture there. And the smoke there, we're there about 5 hours. And the smoke from that, it's burned very aggressively. We went further on to the fire on the left-hand side there. And the smoke was reaching Jasper National Park by the time we left 4 or 5 hours later. It was just going like gangbusters. And so, spoiler alert, fire and the weather, that's my passion, that's my life, and I view everything with that lens. So I believe in hot, dry, and windy is really critical to fire, though you can get away with just dry and windy. So I'm going to talk about that. If I had time, I'll tell you all about the partnership, but catch me if you want to learn about the partnership because it's kind of a unique situation. And brief outline, just big picture. I could do global fire, but I want to stick to Canada fire, and then climate change, impacts of climate change on wildfire. So in Canada, there's statistics that go back, just like BC, to 1919, 1918. They're not very reliable as you go farther back in time, especially at the national scale. So since 1970, they're kind of more reliable. Our area burned is currently about half the size of Nova Scotia burns every year. It's doubled since the early 70s, and colleagues and I attribute this to human-caused climate change. I can't be any clearer than that. Not just climate change, but human-caused climate change. We published work in 2004 that states exactly that. So BC, right now, because of 2017, your 10-year running average has gone up. It's about 1,600 fires. That hasn't changed much, but last year now bumped your average to 260,000 hectares a year. It's been, 2009 was busy, 2010 was busy, and then 2017 was crazy. Area burn in Canada and in BC is highly episodic. It changes from year to year. I would argue mainly because the weather changes from year to year. Lightning fires, and we've heard numbers for BC, but for Canada, it's about 40% of all fires are started by lightning, but they are responsible for 80 to 90% of the area burned. The last thing I want to point out is 3% of the fires are bigger than 200 hectares. A hectare is about the size of a football field or soccer pitch. And I'm glad to see everyone here instead of watching the World Cup, because I've been watching the World Cup anyway. The important message here is all about the extremes. These 3% of the fires burn 97% of the area burned. Western United States, it's 1% of the fire burns 99% of the area burned. For fire, it's all about the extreme, and I would argue extreme weather. But this is really key and the central message throughout my talk. It's all about the extremes. The tail wags the dog. So this isn't a BC problem. It's not an Alberta problem. We've had lots of fire in Alberta. These are evacuations. This is courtesy of the Canadian Forest Service from Natural Resources Canada. And you can see, or hopefully you can see, the yellow dots indicate how many people were evacuated. And you can see evacuations go from sea to sea to sea, all across Canada. It's a Canadian problem, and it's actually a global problem. So this is work done by a former student of mine, Lynn Johnston, now with the Canadian Forest Service, and it's looking at the human-wildland interface. And the standard wildland-urban interface called WUI, but we also define a WI, a wildland industrial interface or infrastructure interface. And it shows where people and the influence of people is kind of pushing farther north into our forests. And where there's people, there's fire. So let's talk briefly about fire management. Canadian fire management agencies are among the best in the world. We use something called the Canadian Forest Fire Danger Rating System. philosophy historically has been the fire is bad and you want to put it out. Now, that's not always the case because fire is natural in many situations, and so you want to balance. And some agencies are now allowing fire when and where possible on the landscape, and it's called appropriate response. But if it's unwanted fire, the idea is to hit hard, you hit fast. If the fire is the size of this room, if you've got an experienced crew, it's not a problem to put it out. If the fire gets the size of a football field and it is hot, dry, and windy, and the fuels are conifer or grass, you now have a problem. Smokey had two messages. One was, you can prevent forest fires, which is a great message, but the other one was that fire was bad. And fire is not bad. It's, in many cases, just Mother Nature doing her job. So here's showing fire polygons from across Canada. And you can see, once again, it goes from C to C to C. And 2017 was added, and that's the red areas in British Columbia. And prior to that, it would say, hey, British Columbia's doing a pretty good job putting fires out. Or, we just haven't had the occasions where there was a severe fire year like last year. Though in 2009, 2010 were severe fire years, just the fires were managed to a large extent, whereas last year was just exceeded a threshold and were really difficult to deal with. And we'll show you a slide later about how much area did burn last year in British Columbia. So, you may forget most of my talk, but remember this slide, okay? This is the 3 ingredients you need for fire. And, I think everyone realizes this, but let's just state it. Fuel. What type of fuel? Conifers burn much more readily than deciduous trees or broadleaf. How much fuel? What's the fuel moisture? How is it structured? We often talk about ladder fuels. The fire starts in the forest floor and can be carried up into the crowns of the trees if you have ladder fuels, shrubs, or branches that come close to the ground like black spruce and things like that. So that's the fuel. Then ignition, people and lightning. And then there's weather, the hot, dry, windy weather as I call it. The extreme weather is really critical because most of those large fires that burn most of the area burn happen on a relatively small number of days. And you can think of July 14th, July 7th, last year in BC, the extreme days. So I argue that weather is the most important. They're all important. You need all three for a fire to occur. And of course, and then there's other factors like people that influence the mix. But as long as you have these 3 ingredients, and fire was around before there was people on the landscape, as long as you have these 3 things, you will have it. Weather influences the other 2 ingredients. Lightning is a function of the weather, and fuel moisture is really critical for fire starting and spreading, and fuel moisture is a function of the weather. So I'll just point out that bottom right-hand picture is taken near Fort Smith, and that's not steam, that's smoke coming from a peat fire. This is November 2014. That fire persisted through the winter and popped up the next spring. So we spend $800 million a year on wildland fire management. And it's been rising and rising. Last year, probably top $1 billion. BC alone spent $500 million for obvious reasons. Health and safety of Canadians, protecting timber. The more we find about smoke, the more we find out how bad it is. And traditional approaches of fire management may be reaching their limit, economic and physical effectiveness. Fire management agencies are very adaptive. So that's why I say may. Fire is like real estate, okay? It's location, location, location. If the Fort McMurray fire occurred 100 kilometers to the east in northern Saskatchewan, it wouldn't have been a big thing. Those 2,400, 2,800 structures wouldn't have burned, okay, in 2016. The only thing you'd hear about is maybe the Star Phoenix in Saskatoon would say, oh, there's air quality is bad because of fires in northern Saskatchewan. So location is really important. Slave Lake, fire started close to town. Fort McMurray, 2017, we've seen pictures from Chile, Portugal, Spain, South Africa, Ireland. Yes, Greenland, that's not a typo. Greenland had some serious fires last year. They've had fires in the past, but nothing like they had last year. And of course, BC, Alberta territories, Saskatchewan, Manitoba. And globally, smoke-related fatalities are estimated at 330,000 people per year, mostly Southeast Asia, haze from peat fires. So you've seen slides similar to this. This is from Mauna Loa, which has been recording carbon dioxide in the atmosphere since the late 1950s. And you can see it's going up and up and up. There's some little wiggles there in the 70s from some gas shortages and things like that. But it's going up and up. And it's over 400 parts per million. Pre-industrial was about 270, 280 parts per million. So it's a greenhouse gas. Simply put, we receive our energy that drives our climate system from the sun. Sun's about 6,000 degrees. It sends its energy in short waves, okay? Earth is about 300 degrees temperature. It emits radiation as long waves. There's certain gases like water vapor and carbon dioxide that allow the incoming shortwave radiation to reach the Earth, but keep the long-wave radiation from going back out into space. It's like putting a blanket on your bed on a cold winter's night. It keeps you warmer, and that's exactly what these are doing. There's a natural greenhouse effect even without our additions from fossil fuel burning, and this is why we have such a good temperature for life on our planet. Venus has much too much greenhouse effect. It's about 500 degrees at their surface. Mars has too little and it's too cold. Of course, the distance from the sun also plays a role. And let's hold our breath and see if animations work on this. And oh my goodness. Okay, so this is where we use our imaginations, and this is showing the global temperature and the changes since the 1880s. And what you see is, there's a whole bunch of blue. It's cold, cold, cold. And then late 70s, the Earth becomes a much, much warmer place. And so I guess I should have checked that this morning or used my own computer. So we've seen curves like this before. We're warming right near the end. You can see it's starting to go really high up. 2016 was the warmest year on record. Almost all the warmest years on record have occurred this century, except for 1998, which was a very strong El Nino year. 2017 was the warmest non-El Nino year on the globe. So here's just showing warm temperatures and record warmest. This is 2016, and you can see a lot of the Earth is warming. Not everywhere. There's a lot of spatial variation. In some places, like the southern oceans and parts of areas in the northern Atlantic, had no change or even cooling, and that's because ocean dynamics, ocean currents, play a major role in our climate system. This is a relatively new graph because we passed 400 months of our global monthly average temperature being above the 1951 to 1980 normal. So the last time it was globally below the average was December 1984. I gave my first talk on climate change in 1985. And at the time, I was on the fence. I wasn't sure. I was giving the talk for a colleague, but shortly thereafter, I became convinced. And if this doesn't convince you that something's going on, I don't know what will. So, climate change. We use global climate models, general circulation models. Serge, do I get $2 because I explain the acronym with both, okay? Older people call it general circulation models, new people call it global climate models. They suggest warming up to 6 degrees, and as we've seen from Mel and Greg, higher latitudes, generally over land, winter and spring, except for the Arctic Ocean may become seasonally ice-free. Originally they said 2050s, now some people say 2030s. But it's really the changes in extreme weather that are concern to people, okay? And things like drought and fire and floods. And we are seeing this more extreme weather, and I'll talk more about jet streams in a bit, time permitting. And the spatial temporal variability from year to year. So here's another mission. At least you can see the map this time. So this one rarely fails, but yeah, okay. So once again, once you see it, it's lots of warming occurring, and you can see at least the legend on this one, and you can see 5, 6 degrees, and that's what you start to see over North America by the end of the century. So this is work done